Hi, my name is Yuri Yagi, and in this video I'll be going over arc length, which you will need to know for the AP Calculus BC exam. So to start, what does arc length tell us? Arc length tells us, so we'll start with Cartesian arc length first. So for Cartesian points, the arc length of a function, so let's say this function f of x here, and we want to find the arc length from a to b. That arc length, L, is equal to the integral of a to b, the square root of 1 plus f prime of x squared dx. And this is assuming we have a function f of x. For parametric functions, let's say we have a parametric curve like so, where we're given x of t and y of t, like so. The length for a parametric arc length is equal to the integral from a to b of the square root of x of t squared plus y of t squared, and then dt, obviously. So those are the two formulas you need to know for arc length, the Cartesian formula and for parametrics. So let's try out a problem. Let's say we're given the problem x equals 3t squared and y equals t squared, and we're just asked to find the arc length from 2 to 4, x equals 2 to x equals 4. So in this case, we first want to find the derivatives. So x prime of t is equal to 6t, y prime of t is equal to 2t. Now we plug it into the arc length formula. So for integral from 2 to 4 of the square root of x prime t squared, which is 36t squared, plus y prime t squared, which is 4t squared, so 40t squared dt. We do some rearranging. We can move the constant square root 40 outside the integral, like so. And t squared just becomes t, so t dt. If we integrate that, what we get is square root of 40 times t squared over 2 from 4 to 2. And what we get from this is 16 divided by 2 is 8 squared 40, minus 2 squared is 4 divided by 2 is 2, 2 squared 40, which is equal to 6 squared root 40 as our final answer. And of course, we could do something with the square root to make it more simplified, but that's fine. So again, the process is we take the derivatives, plug it into the formula, and then we evaluate for the arc length. Let's try out another problem. This one's a little harder. Let's say we're given the function f of x is equal to the ln of secant x, like so, and we're asked to find the arc length from x equals 0 to pi over 4. So first steps first, we have to find the derivative. So derivative of f prime of x is equal to, so chain rule, we do ln secant x, so ln would become 1 over secant x using the chain rule, because ln is equal to 1 over x, or 1 over u. And we take the derivative of the inner. The derivative of secant x is secant x tangent x, like so. And we see that the secant x cancels out. We get tangent of x for our final derivative. Now we can plug this into the arc length formula. We get arc length is equal to the integral from 0 to pi over 4 of the square root of 1 plus f prime of x squared, which is the same thing as 1 plus tangent of x squared based on our formula. If you guys are up to your trig identities, you should know that 1 plus tan squared x is equal to secant squared x. So in other words, the integral from pi over 4 to 0 of secant of x dx. And we should know that the integral of secant of x is equal to ln of secant of x plus tangent of x from pi over 4 to 0. And now we can just plug it in. So if we plug it in, what we get is secant of pi over 4 is 2 ln of 2 square root of 2. Tangent of pi over 4 is just 1. minus secant of 0 is just 1. Tangent of 0 is 0. So ln of 1 just becomes 0, right? So we're left with ln of square root of 2, or sorry, 2 over square root of 2, which is the same thing if we rationalize as square root of 2. So we're left with the answer, ln of square root of 2 plus 1. And that's the arc length from 0 to pi over 4 for f of x. Okay, so that's how we do arc length, and it's pretty simple. All you have to do is remember the formulas, and process is just take the derivatives, plug it into the formulas, and evaluate for your final answer. And yeah, that's how you do arc length. Thank you guys all for watching, and I'll see you guys all tomorrow. Bye.